So before we get into the nitty-gritty, let's get a high-level view of what Inspector is. First, let me say that I've been developing software a long time, and there have been quite a few tools that do similar things to Inspector. One of the older tools was Bounds Checker. I used to use that all the time, and it saved my hide on a number of occasions. It would let you know when you wrote outside of any kind of allocated memory space. One of the more recent tools is DevPartner. And DevPartner is a really good tool, but it's very large, very kind of bloated, and it's also very expensive. That's why I really like Inspector. It's part of Parallel Studio, and it does everything that I really need it to do. So it can find memory errors, such as when you forget to deallocate memory. It will find memory errors when you overwrite the bounds of memory, and it will also find threading errors. That's the majority of the unintentional bugs that find their way into my C++ programs. In addition to that, these are extremely difficult errors to find and debug. Okay, here I've created a basic project. And before I get started, I want to go ahead and make sure that my project properties are all set up the way they should be. So let me open up the properties, and I'll go to C++ General. And let's just make sure the debug information is set the way it should be. We need to have ZI, program database. Then we'll go to the optimization and make sure it's all turned off. Then we have to go to code generation, and we look at the runtime library. It can be either multi-threaded DLL or multi-threaded debug DLL. So I'm going to pick that there. And lastly, I'm going to go to the linker and check debugging and make sure that it's going to create debug information. That's all I do for the properties. Okay, so let's start with one of the classic C or C++ memory errors. It's when you allocate memory and somehow you don't delete it. Now, I teach computer science at the university level, and I teach an intro to C class every so often. And invariably, students make a lot of mistakes when it comes to memory allocation and deallocation. Now, sometimes they just flat out forget to deallocate the memory. But more than likely, it's a subtle or hidden thing that causes them not to deallocate the memory. Let me give you an example here. Okay, I've created this function, and I call it, and it opens a file, allocates a huge buffer, reads in the contents of the file, and closes the file handle. Now you might say, well, anybody could see that this was allocated memory that needed to be deallocated. However, sometimes there's a global variable that has the same name, and people are counting on using that global variable. Sometimes people just inadvertently or automatically or subconsciously type this in, and they don't realize that they typed in a local variable of the same name as the global variable. So in order to catch this error and see what's going on and what the problem is, we're going to run Inspector. And we just go up here, and we'll go to Inspector, and we'll select Memory Error Analysis. And this is what you're going to use when you want to detect leaks. So it's going to go and run. It runs the program, and while it runs the program, it's doing the analysis. Okay, the program's done. It doesn't really do much. And it finishes up its analysis. Now you can see it detected one memory leak error. And if you double click on it, it shows you the exact line where the memory leak occurred. This is where it was allocated and was never deallocated. I can tell you right now that I've had many times in my career where I would have given my eye teeth for something like this. Okay, so the second most common memory error in C and C++ is overrunning a buffer. So here I've created a function, and I opened the same file. I allocated a buffer, 1755 bytes, and I read in whatever the file length of that file was. I read it in. Now that file happens to be 1757 bytes. So when it reads in according to this, it's going to overwrite that buffer. And a lot of times in C and C++, this produces very unpredictable results. And I've had times when it worked perfectly on my computer, and then I shipped it out to have someone else use it and it crashed. So these are very difficult errors to find, but we're going to go ahead and use Inspector to help us out. So this time I'm going to run Inspector, and I'll say memory error analysis, locate memory problems. So it's going to run and collect information. And it's a short program, so it doesn't take long. Then it will do the analysis. So here's the summary. It's got a memory leak because I never fixed that. But here's the invalid memory write. So this is going to pinpoint the exact line where it overran the buffer. The last situation we're going to talk about is with regards to data races among threads. So here I created two functions that kick off a couple of threads, and these are pretty straightforward, creating threads and getting them going. But you'll notice that the two thread functions write to this same variable, okay? And they continue to do so, and because there's no synchronization mechanism, there's a high likelihood you're going to get some sort of a data race. So in order to find this, we're going to rely on Inspector once again. Instead of the memory analysis options, we're going to run threading error analysis. We'll go ahead and run this. And this takes a few seconds to run because I put asleep just to make sure that there was plenty of time for the data races to happen. Okay, it's done. Now I'll look at the summary, and it's going to show me that I have a data race condition. It's really nice because you can see in one function and then the other, and it's going to compare them and show you where you've got that data race condition in both functions. So excellent job, Inspector. So in conclusion, Inspector can find many, many errors. This very short demo just scratched the surface, but even what I showed you will save you many, many hours of debugging. Two of the memory errors that we looked at were memory that wasn't deallocated and a buffer access that exceeded its bounds. We also looked at a data race condition between two threads. I highly recommend that you at least download the trial version of Inspector.